Now, this is basically our topic 3, which we're talking about. The worksheet which you would have done is the diffraction, and interference. This is based on the PMT website, and this is based on topic of waves. Now, this is our first question, which deals with the de Broglie wavelength of the electrons in the case of a proton and electron. Now, as you can see that the mass of a proton, this actually confuses a lot of people. As you know, de Broglie wavelength is equal to lambda, which is equal to h divided by mv. Now, however, you were a bit confused in this case. The answer should actually be A. Why? Because in the case of the lambda, in other words, the wavelength of the electron should be actually more than the wavelength of the proton. This is what you have to remember. Why? Although there's actually an inverse relationship, however, due to the mass of the proton actually being considerably smaller, 9.11 into 10 raised to a minus 31 compared to mass of proton, which is equal to 1.67 into 10 raised to a minus 27. This results in our answer being being A. Then we come to our fourth question. This again, it's a bit of a confusing one, but it basically tells us about the diffraction patterns is formed by passing monochromatic light through a single slit of width of the single slit is reduced. However, what happens to the in other words, which of the following is actually true? Now, you would actually see that the answer to this question is in fact number C. In this case, it will be number C here. Why is it number C? In other words, they're saying that the width of the central maxima will increase. However, the intensity of the central maxima will decrease. Why? Because it is more spread out according to this formula. You're on the right track, but you sort of thought that it should increase the intensity of the central maxima. No, because the more converges, the more spread out the intensity actually will decrease. But if it's concentrated in one point, you can actually see that the intensity is very, very strong. Take an example of a magnifying glass. When you concentrate the converging light onto a piece of paper, because the center of the white spot is formed. That's very constant, maximum intensity. If you, the more and more you can say increase the distance of the microscope of the magnifying glass from the piece of the paper, you can observe that actually white light is becoming less and less intense, resulting in our based on this application, you can say that the answer is actually C, that the width of the central maxima, as you were correct, that it will increase as obviously we dispersed more. Diagram also you drew very nicely. But then the intensity of the central maxima will actually decrease respectively. Moving on to our question number 3. Now again, this question number 3 will, this is basically a bit confusing, or that actually the answer is C. Why? Now they say a light source of emits the, basically it tells us that two wavelengths, lambda 1 and lambda 2, and the wave is incident on a diffraction gradient, is found that the fifth order of light of wavelength 1 occurs at the same angle as the fourth order of wavelength of number 2. If lambda 1 is 480 nanometers, what is lambda 2? Well, your answer should have been, in fact, number C. In fact, it should have been 600 nanometers. Again, you should use it on the basis of the n lambda is equal to d sine theta. So remember to do this. Moving on to question number 4, you were correct in stating that yes, when comparing the X-ray and the ultraviolet variation, which statement is correct? But basically, it should be that using the same element, the photoelectrons emitted using the X-rays have a greater maximum kinetic energy. Why? Because you can see that as we go down the spectral series, we see that the wavelength increases, but the frequency increases, but the wavelength decreases. Now, in the case for our maximum kinetic energy, we see that is equal to E is equal to H into F. Now, how higher the frequency is, that corresponds to a high energy, as we know that in the case of the X-rays, it will have a more maximum kinetic energy, resulting in option D being the correct answer. Now moving on to our question number C. Basically, our question number 5 says a monochromatic light may be categorized by speed, frequency, and wavelength. Which of the following quantities, when a monochromatic light passes from air, in other words changes, should actually be the speed and the wavelength only? Why? Obviously, speed will change because it's going from a rarer to denser medium, air being the rarer and gas being the denser, but actually wavelength also changes, funnily enough. Wavelength, you would think that some people are using speed only, but actually the wavelength will change as well, due to the speed is equal to c by lambda. A cute furry ram, if you remember, or very cute lamb. So that also leads to the variation of both the values of lambda being the wavelength and the speed respectively, which brings us on to our 6th question. Basically, question number 6, the answer you should have got is A. Again, this is based on the monochromatic light of a wave. This is based on, again, the formula of n lambda is equal to d sine theta, giving us a value of the question A, which is the first order observed of the angle is at 17 degrees, giving us this as our answer here. Question number 7 is also very, very important at how this happens. The answer which you should have got is A here. That it says that in a double-slit experiment, basically is used to produce interference fringe. The separation of the slit S and the width of the slit is X. L is the source of the monochromatic light. Which one of the following changes would decrease the separation of the fringe of the screen? If you would move the screen closer, in other words, if you shorten the distance of D, this will lead to a decrease in the fringe width, respectively. Moving on to our question number 8. Now, question number 8, the answer to question number 8 is actually D. You were correct. Very good. Because it actually says that as the separation should change to D by 2. If the separation between the basically the two slit distances should increase by separation, in other words by d by 2, the actual fringe width will increase by a factor of 2, as these are inversely proportional to each other, resulting in the formation of a spread out as compared to this is D, the separation. But obviously, as you can see, a fringe width here will be all by 2 times this, so separate by 2 times. Where it was narrower, it become slightly broader with a factor multiple of 2. Question 9 should have given you the answer of A. Question 10 should have given you the answer of C. Question 11 should have given you the answer of, again, C. Question 12 should have given you the answer of D. Question 13 should have given you the answer of D. Question 14 should have given you the answer of B. Question 15 should have given you the answer of B, which is correct. Very good. Question 16 should have given you the answer of A. These questions then I will read in detail to you in a later video. Question 17 should have given you the answer of A. Question 18 should have given you the answer of C. Question 19 should have given you the answer of B. Well done. Question 20 should have given you the answer of D. Well done. Question 21 should have given you the answer of C. Question 22 should have given you the answer of B. Well done. Question 23, the first part, should have given you an answer of A. The B part should have given you an example of D, answer of D. The 24th question should have given you an answer of B. Finally ending with the 25th question, giving us an answer of C, respectively.